Hello student, welcome back to my channel. So today we will discuss here about the next topic, which is here Pascal law in hydrostatics chapter. So here when we talk here about the Pascal law implies us about when we apply some pressure at any point on the given liquid which is incompressible, it is equally distributed all other points of the liquid and also the wall of the container in which the liquid is filled. So here when we write the definition first, we can say according to this law, if the effect of gravity is neglected, the pressure applied at any point in the liquid is equally distributed to all other points and also the wall of the container, on the wall of the container. Hence we can say that this law, Pascal law is for, we are seeing here, is for transmission of liquid pressure. So this law is for transmission of liquid pressure. Also we can write this statement along with this law. So see, when we think about the diagram here a spherical container is placed in front of you in which A, B, C, D, 4 chambers are attached, or 4 faces or mouths are attached, so that in which we have a cylindrical shape connected with a frictionless piston. Okay, so the area of cross section of each face or each mouth here is different, like A 3 times of A, 2 times of A by 2. So when we apply, supposed to be out of these corners, when we apply some external force from one corner, means from point A, if we are noting here corner A as point A, B, C, D. So for if we think about point A, if we are applying some external pressure by the force F on point A, then for point A pressure exerted, or you can say pressure applied, P is equals to F upon A. Point clear? This is the pressure applied on point A, and by Pascal law, we know that this pressure is equally distributed all other points of the liquid. So we can write here, if we think about here, this is for point A. Now, if we know here the pressure PB is equals to, it should remain same, because according to the Pascal law, the applied pressure is equally distributed all other points and also the wall of the container. So here we have only 4 points which we are taking here. So we can write PB. PB pressure will be like that. The result should be what? F upon A. So here we can see the area of B is equals to 3 times of A. So the force which we will apply here to maintain the pressure P is equals to 3 times of F, so that we will get the final pressure F upon A. This will be small a. So similarly PC is this one in which the area is twice of A, so the force which we will see here is 2 times of F. It is equals to again F upon A. Now similarly for PD, in which the area is half, then force will also half, so that we will get the final result F upon A. So out of these we can write here PA, PB, PC, PD is equals to F upon A, which is here supposed to be considered small p, so we can write this is equals to P. So this is the transmission of liquid pressure in the given fluid under the Pascal. Point clear? So this is the statement of Pascal law, and this calculation is the derivation of Pascal law with the help of this demonstration. Point clear? After that we will write here about the application of Pascal. So here we will discuss about the application of Pascal law, application of Pascal law. So first application is hydraulic lift. After that we will discuss here about the hydraulic brake. So in case of hydraulic lift, you can see the diagram. We have U-shaped pipe having different cross section area. One surface is enlarged. We have two cross section area here, which is connected with a two cylinder C1 and C2, and their cross section area is supposed to be here A1 and A2, and inside this pipe liquid is filled. Point clear? So here, as we know that this is the application of a Pascal law, so here F be the force which is applied on it, and if you want to see here the area A1 by small a, because the area is for a small part or small reason, and the capital A is the area of large cross section area in which the weight is placed. To lift that weight, we will apply the force as if we are suppose lifting this body. This is a weighted body directly like car, truck, etc. This is a weight, heavy weight. So we are lifting that weight with the help of field pressure by applying small force. So directly if you want to lift that weight, we need more force to lift that particular weight in particular height, but with the help of this Pascal law, we can easily lift that weight by applying small amount of work done, or you can say by applying small pressure on the given small cross section area. We can lift that particular weight, which is a heavier weight like car, truck, which is placed on the large cross section area placed. Point clear? Now see, we will discuss here. This is a diagram of hydraulic lift. Okay, and this pipe is supposed to be represented by E, and C1, C2, A1, A2 are the area of cross section. So here, according to the working of this hydraulic lift, on applying small pressure, we can lift heavy objects easily, okay, by the effect of hydraulic, or by the transmission. We can add one thing, by the transmission of liquid or fluid pressure. Point clear? So see, initially we have, according to this diagram, we have C1 comma C2. From this diagram we have C1 comma C2 are two cylinders having different cross section area, so that A is less than capital A, and connected with a pipe E with frictionless pistons, as you are saying here. So therefore pressure exerted on small cross section area by applying force, external force, this is student F. Point clear? Small cross section area is our A. So therefore the pressure in this side is P is equals to F upon A. Now in second part we can see, as we know that by Pascal's law, this pressure is equally distributed to all other points of the liquid and also the wall of the container. So this pressure is transmitted to that cylinder C2, so that this pressure is used to lift that heavier object which is placed on the other terminal C2, having cross section area capital A greater than small. So we know that by Pascal's law this pressure is equally distributed to the other end. So student, when this pressure is equally distributed to other end, then the pressure remain constant. Listen carefully, the pressure remain constant on this side, but the force will be different. The pressure here also is P, but the force we don't know. So therefore we can write force on the other end to lift the heavy object, or you can say heavier object. So it will be F is equals to P times of A, and this P is equals to, we know that small f over A into capital A is this. So we can write here F is equals to, if you want to write here this formula in this way, F over small a is equals to capital A over small a. Suppose to be, this is our second equation, and this is the value of this second equation. So this is the value of force exerted on the vehicle or the heavier object placed on the cylinder C2 with the help of Pascal's law by applying small force F. We will see what amount of force we will observe here. Is it greater or smaller? To observe this, we will focus on the second equation. Since from the diagram you can see here A, capital A is greater than small a, from the diagram you can see easily. So by this relation we will see here, it implies capital F will be greater than smaller f. Hence we conclude that the force exerted on the other end C2 is greater than the force exerted on the end C1. Hence we will observe a greater force on applying a smaller force on the other end of the lift. So this one is the very famous or daily life useful application of Pascal. Point clear? So hence, by applying, we can write this statement according to this, by applying this one, by applying small pressure, we can lift heavier objects. Point clear? By the transmission of liquid pressure. This is the proof of this hydraulic lift. And after that, we will talk here about the next application of Pascal law, which is a hydraulic brakes, in which we will see how on applying the small amount of pressure in pedal, we will observe that the large vehicles, the wheel of the large vehicles will stop easily by applying small amount of pressure on it. So for that, pause the video and note down. After the discussion about the hydraulic lift, the next application of Pascal law is hydraulic brake. Hydraulic brake is also based on, we can write here, based on Pascal's law. Point clear? So here you can see the diagram. In this diagram we have two cylinders. One is wheel cylinder, another is master cylinder, and another third object which we have, it is tube, in which one terminal of that tube is connected with wheel cylinder and the another terminal is connected with master cylinder, and inside this tube and the cylinders the brake oil is filled. When we apply here some force, external force, when the driver applies some external force by brake pedal to that piston, it pushed away from it, and the force exerted by this brake pedal or the pressure exerted by this brake pedal, which is transmitted to this piston P1, is also transmitted to the another pistons P1 and P2, which is connected to the horse, which is connected to the brake shoe S1 and S2 of the wheel. When this pressure is transmitted to that P1 and P2 piston, it becomes move away from each other so that it will apply a force on these brake shoes. Hence, we will observe that the brake shoe will displace away from each other and apply a retarding force on the rim, inner rim of the wheel, so that we remove the brake from this brake pedal. Then we will see that this piston P will come in their back position or initial position. So the same point, this P1 and P2 comes back, and the force brake, apply a force on the brake oil so that the force again transmitted from P1 P2 to that P piston which is in master cylinder. Hence we will observe that during this process, when the force applied by the brake pedal, which is transmitted through the master cylinder to wheel cylinder, as we know that here the condition is the area of cross section of wheel cylinder is greater than the master cylinder, due to large amount of area, less amount of pressure is required to stop the wheel or to retard the wheel by the driver. So that's why we will put here large cross section area in wheel cylinder as compared to the master cylinder. So this is the condition of, you can say, the oral discussion about the hydraulic brake. If we want to write here about the points here, so we can write here, we have a tube T whose one terminal terminal is connected with master cylinder and other is in wheel cylinder. Point clear? Now after that P, P1, P2 I am writing here in short are the pistons as shown in figure. S1, S2 are brake shoes connected with piston P1 and P2, P2 and inner part of rim. Point clear? Now the procedure is that when the driver applies brake, the pedal pushes the piston P through lever system and piston P transmitted the pressure to P1, P2 piston of wheel cylinder by liquid which is here brake oil by the transmission of liquid pressure. As a result, P1, P2 move away from each other and the brake shoe connected with them also moves away and retard the motion of inner rim of the wheel. Since wheel cylinder has greater area of cross section as compared to master cylinder, therefore by P is equals to F upon A, P is inversely proportional to A, it implies, we can write this thing here, less pressure is required to retard the motion. Point clear? This is the way to to represent it here. And after that, when next point, on releasing the paddle, P1 comma P2 piston comes back and exert a reverse force to brake oil and the piston P also back to its position. The same pressure is exerted by the brake pedal to each wheel of the car or bus, etc. Clear? Now after that we can say here, hence, now the final conclusion, hence by applying, hence the driver controls the vehicle by small pressure. Means by applying small pressure, the brake, through this brake pedal, the driver easily controls the whole vehicle, car, bus, etc. So this is the explanation which is based on hydraulic brake. So here the focus point is that, as we know that here initially we have the wheel cylinder which have greater area. So the wheel cylinder, why it is greater in area as compared to the master cylinder, because we know that, again I am writing here, P is inversely proportional to area. Large area, less pressure is required to do the same amount of work. Point clear? So here, that's why this is the reason, or conclusion, we can say that this is the theoretical explanation of hydraulic brake, which is the application of Pascal'law. So after that we will discuss here about one numerical based on the application on Pascal'law. Two syringes of different cross section area without needle, filled with the water and tightly fitted with rubber tube of diameter of smaller and larger piston are 1 cm and 3 cm. So we have diameter of smaller 1 cm, which provide us the value of A1, which is equals to, as we know that, pi r1 square. It means that pi d1 by 2 whole square. And next one is here d2, which is equal to 3 cm, which provide us A2 is equals to pi r2 whole square, pi d2 by 2 whole square. Point clear? So after this calculation, we will easily calculate here the first value, find the force exerted on the larger piston. So here supposed to be, we consider the force for smaller piston is denoted by P1, F1, and for larger is F2. So we can use here the condition of hydraulic lift, F2 by F1 is equals to A2 by A1. With the help of this formula, we will get the value of the force exerted on the larger piston F2, which is equals to A2 by A1 of F1. Point clear? So now we can calculate the value of this calculation for F2. So we can write here pi d1 upon 2 whole square over pi d2 upon Just wait, here A2, we will write here D2. So D1 upon 2 whole square of F1. Point clear? So here pi to pi cancel, and after that we have given here if the force is 10 Newton. So it is given us F1 is equals to 10 Newton. So after this our calculation will be for F2. For F2 is equals to d2 by 2 into d1 by d2 upon 2, d1 upon 2, 2 to 2 cancel. So I can write here d2 by d1 whole square of f1, and see here it will be the value of f2. d2 we have here 3 centimeter, so 3 into 10 raised to the power minus 2. And next one is 1 into 10 raised to the power minus 2. Point clear? Yes. Next, whole square into 10. This to this cancel. 3 3s are 9. 9 into 10. It will be 90 Newton. So, see student, on applying only 10 Newton of force in smaller piston, you will get a pressure of force 90 Newton in the larger piston by using Pascal'law application, or you can say by Pascal'law. Point clear? After that, we will talk here about if the smaller piston is pushed in through 6 centimeter. Suppose the smaller piston, here the diagram is just like same as we have drawn. See, this is a piston here. Now see, if according to the diagram or according to the given information I am writing here, if the smaller piston is displaced by 6 centimeters supposed to be, so how much does the larger piston will move? So L2 movement is question mark, and as we know that here the volume of the liquid displaced by applying the force in larger and smaller will remain same as if we talk here about the equation of continuity condition. So we can write here the volume of water, since the volume of water remain same, therefore the volume means volume for volume of smaller piston, means volume of water replaced by smaller, we can say small volume for smaller piston. Clear? It will be our A1 into the displacement of this L1. So similarly, the volume for larger piston means volume of water from the side of larger piston. We can write here A2 into L2. As we know that these two are equal, so it implies that A2 into L2 is equal to A1 into L1. Point clear? Now we want to calculate the value of L2. So L2 is equals to A1 into L1 upon A2. Now here L2 is equal to A1, we have what is the value of A1? A1 is here in front of us, so we can write A1 upon A2 of L1. L1 we have 6 centimeter, no problem. L2 is equals to A2 upon A1 upon A2 pi. Again I am writing here D1 upon 2 whole square pi d1 by 2 whole square pi d2 by whole square into L1. Point clear, student? So see here pi to pi cancel, and after that L2 is equal to what we will write here. L2 is equal to d1 upon d2 whole square into L1. d1 upon d2 whole square means d1 is here, d2 is here, 1 upon 3 whole square. So we can write here the calculation 1 upon 3 whole square into the value of this L1. L1 we have 6 centimeter. So 6 upon 3 3 is 9. So it will be 9 point, first point 54. It means it will be near about 0.67 cm. So this is the calculation answer in front of you, which is based on this numerical. So similarly you will do all other numerical which is based on this concept at your home. So after that we will talk here about the next topic. So pause the video and note down. Effect of gravity on fluid pressure. Point clear? Here, as we know that pressure, common formula when we talk here about the pressure formula, force over area. Point clear? When we write here about the pressure on liquid, or you can say the fluid pressure when we are talking here, so it means that the force can be written here that weight form, and weight is equals to mass into gravity. Point clear? And this mass is equals to volume into density. Listen carefully student. And into small g. And this volume we can write here area into height into density into small g. So here we will use the formula of this force, which is, because here we are talking about the fluid pressure. For this fluid pressure we can write the another formula, area into height into density, which is noted by supposed to be rho, into acceleration due to gravity g. So we will write the all values here, a into h into rho into g over a. So it will be our p. So after cancellation of this, we will write here h rho g or rho g h, whatever you want to write, rho g h. This is the value of pressure, which is called fluid pressure here. Now here we want to show the relation between the fluid pressure and the acceleration due to gravity, because here we want to show the effect of gravity on fluid pressure. So we can write from this relation P is indirectly proportional to small g. Now we will focus about the value of g in different places. When we want to know, because here we are talking about the effect of gravity, when we want to know the places, hill places, at hill places you know that the value of g is inversely proportional to the height, or the height of hill. Means when we move toward the, means from plain surfaces, from plain areas to hilly area, when we want to move, then we know that the variation in g, as we discussed in gravitational chapter. So the variation in g means that the g is inversely proportional to the height, and we know that here p is directly proportional to g, comma p is directly proportional to g also. So from these two we can write here the p, which is fluid pressure, is also inversely proportional to h. Means at hill places the fluid pressure becomes less than the pressure, less than the plane area, or you can say is less than the plane areas. Plane area means these are the hilly area, we are talking about hilly area, and this is our plane area. Point clear? And second thing, when we want to know about the depth, we want to see d depth below. D depth below the surface of when we want to write d depth below the surface of Earth, as we know that the value of g, small g, is inversely proportional to d, that time we can say that here again the p, which is directly proportional to g, and we know that this g is inversely proportional to d, it implies us p is inversely proportional to d. Means when we want to know about the fluid pressure inside the surface of Earth, we will see that the fluid pressure is, it becomes again less, it becomes less on the below, or you can say d depth below the surface of Earth, d depth below the surface of Earth, below the surface of Earth. Point clear? So after that we will talk here about next point, third one. If supposed to be small g is equal to 0. Now if the acceleration due to gravity is 0, so that time the fluid pressure P is also equals to 0 from this equation. Now the fourth point is, if suppose we are taking here the free fall condition again. Free fall condition means we are taking, we want to know free fall condition, means we are discussing here about the value of fluid pressure inside the lift which is under free fall condition. So in this condition we know that in this condition and again the value of g is equals to 0, so which implies us the value of p also 0, which is here our fluid pressure. Point is clear? So these are the points in which we will discuss about the effect of gravity on fluid pressure. So your hydrostatic part is completed here, and your hydrodynamic part we are completing in Google Meet classes. So do this part and join the Google Meet class to understand. Okay.